Okay, so the last time for homework, I asked you guys to measure different circular items, and that was called the circumference, if you remember. The circumference is the distance around a circle, the perimeter of a circle. So I asked you to measure the circumference of a circle of various items around your house, as well as the diameter of the circle. So what I did is, it just so happens that I have a table here with the information from several of you. By the time I made this video, I only had a few responses, but I had one from Helene Juarez, Joanie Aracil, Brendan Johnson, Alina Arsenault, Lauren Gonsalves, Hallie Larson, Rachel Kay. So they gave me a few of their items, and I wrote down the circumferences and the diameters of the items they gave me. There was electrical tape, a racquetball container cap, a Pringles cap, Vicks Vapor Rub, which I put an asterisk, very important when you're sick. But anyway, so what I did is I put this data here, and I used Excel to make a little spreadsheet, and I'm going to find the ratio of the circumference to the diameter. Remember what ratio is? A ratio is a comparison of two numbers. So I'm going to divide the circumference by the diameter using the spreadsheet. So I'm going to type in the equal sign like we did for the project to let Excel know that I'm going to enter a formula. I'm going to take this value and I'm going to divide it by this value, and I'm going to press equals. And I got a number. Let me see if I can make this a little bit larger, because that's not easy to read. There we go. Okay, I got a number. Now that number, I want that ratio to be calculated for every single circular item that I did. So I'm going to go to the bottom corner here until it becomes a plus. I'm going to click, and I'm going to drag this down. Okay, and when I do so, we have different circular items here, as you see. Oh, this one looks a little bit off. Oh, because he gave me the radius. Okay, there we go. So we have different circular items here, and we have the electrical container, salad plate, Pringles cap, and we have different measurements, but look at the ratio of the circumference to the diameter each time. It's always very close to 3. Some a little bit higher, like maybe 3.3, some a little bit lower, like 2.99. But notice these numbers are very similar to each other. Is that a coincidence? No, it's not a coincidence. It just so happens that I have some numbers here from a previous year. We had things around the classroom, a smoke detector, a red cashew lid, a ribbon roll. I asked the kids to bring me stuff from home. And again, some numbers are a little bit lower, some are a little bit higher, but they're all pretty close to 3 again. Okay, now it just so happens that I have something here on Sketchpad, and I have a circle. I calculated its circumference here, 49.55, and then its diameter here, and here's the ratio. Notice that I have this number, again, close to 3. If the circle gets smaller, the numbers change, but the ratio does not change. If the circle gets bigger, again, the numbers change, but the ratio does not change. Okay, so this number, I'm sure you've seen it before, it kept occurring so many times. When you divided the circumference by the diameter, we kept getting close to 3. So this number was given a name, and the name is pi. So what exactly is pi? Pi, and it's spelled Pi, is defined as the ratio of the circumference to the diameter in a circle, meaning the circumference divided by the diameter is the definition of pi. And that's the symbol for pi. Okay, now again, we kept getting close to 3.14. If we go back to the tables that we had, it seems like, if I'm not mistaken, I think here Lauren with this pizza container got close to 3.14. Some are a little bit lower, but again, pi is none of those numbers. Pi is irrational. Here's a website with 1 million digits of pi. Okay, it's never ending. No repetition, there's no pattern in it. It is an irrational number. If you notice here in this website, 3.14 is what we usually use, what you've been taught since elementary school to use, 3.14. But pi is not exactly 3.14. Pi goes on indefinitely, never ending. Okay, there's no pattern in it. It's irrational. It's called an irrational number. Okay. So going back to our paper here, if the circumference divided by the diameter is pi, I can work backwards. Okay, think of this as being a 1 on the bottom and being a proportion. If I cross multiply, the circumference times 1 is the circumference, and pi times d is pi d. Ta-da! This is the formula for the circumference of the circle given the diameter. Again, capital C stands for circumference and lowercase d stands for diameter. The circumference of a circle is the formula pi times diameter. Now, if you remember, a diameter of a circle is here, but a diameter is made up of 2 radii. So what some people do is in the formula, they replace the diameter with 2 radii. And then the preferred way of writing it is with the 2 in the front as a coefficient. So this is an alternate version of the same formula if you have the radius. But again, it's the same formula. Again, I'm sure you've seen those formulas before, but this is how it was derived. It's derived from the fact that the ratio of the circumference to the diameter of a circle is pi. And then working backwards, I can solve for c. So the circumference is pi times diameter. And if I solve that for the radius, since 2 radii are equivalent to a diameter, the circumference is 2 pi r. So we're going to do some basic problems like you did, 1 or 2 questions like you did maybe in elementary school, middle school. Okay, so here's a circle, and they ask us for the circumference. Okay, so I'm going to do it 2 ways. The circumference is, they're giving me a radius, so I'm going to use 2 pi r. So it's going to be 2 times pi times 3. So the circumference is 6 pi yards. This is what's called the exact answer. Kind of like when we did radicals, when we did square roots. If we did not round and we kept it with the square root symbol, that's called the exact answer. Same thing here. If I keep the pi symbol in the answer and I don't plug in an approximation of pi like 3 or 3.14, those are all approximations for pi. This is what's called the exact answer, okay? Now, an approximate answer, this is asking you for an approximate answer, is one that would use the pi key in your calculator. Find the pi key in your calculator and press it. Now, if you do that, you'll see it'll give you more digits of pi. So if you were to do this in your calculator, it would be 6 times whatever the pi key gives you, and it's 3.14159926. You don't have to write all these down. I'm just writing it down now because I don't have the calculator in front of me. So when you multiply that by 6, you're going to get 18.8 if we round to the nearest tenth. So again, this is what's called an approximate answer. This is what's called an approximate answer. So if they ask you for the exact answer, you leave the pi symbol in the answer. If they ask you for an approximate answer, plug in preferably the pi key on your calculator because that's the one that has more digits. Okay, you can take a moment to write this down, stop the video. The next one that I'm going to do is one with a diameter. So if we go to one with a diameter, here they're giving me the diameter is 12. So I'm going to use the diameter version of the formula, which is pi d. So it's pi times 12 or 12 pi. So 12 pi yards would be what's called the exact answer. And then the approximate answer would be the one that I use my pi key for. So if I do pi times 12 on my calculator, again, that's going to be pi times 3.14159 ... all the keys on your calculator. That's going to give you 37.7 yards. And again, that's the approximate answer using the pi key on your calculator. If they ask you for exact, you leave the pi symbol. If they ask you for approximate, use one of the approximations for pi, preferably the pi key because it has more digits. Okay, so those are 2 simple examples like you've seen since middle school. Now I'm going to give you some like you're going to see some examples in the real world like you're going to see in your homework. Okay, one real world application of this is in wheel sizes. Notice that here you have different wheels and they have different diameters. The diameter of this one is a lot smaller than the diameter of this one. The distance that you travel in one revolution of a wheel, of a tire, depends on how big it is. What's making contact with the ground as the wheel turns is the outside. So the distance that you travel in one revolution is basically like you take a tape measure and you wrap it around, you lay it flat. So the distance one time around would be equivalent to how far you travel in one revolution. What about if the tire is larger, like this one? Then the distance you travel in one revolution would be longer. So how far you travel with a wheel depends upon its diameter, depends upon its circumference, okay? So let me give you an example of that, something like what you would see. Here I have an example. How far would you travel in 5 revolutions of a tire with a 20-inch radius? Okay, let me put this back. So here I happen to have a tire with a 20-inch radius. Then notice that they don't ask me for the word circumference, they don't say perimeter, they don't say anything. So how would you know it's a circumference problem? Because the distance that you travel depends upon the size of the tire. That's what's making contact with the ground. Any kinds of problems like these would be circumference problems. So use the radius version of the formula. Circumference is 2 pi r. So 2 times pi times 20 is 40 pi. Now that's how far you would travel in one revolution. That's the exact answer, how far you travel in one revolution. Okay, if you multiply that by pi and round it, you get about 125.6 inches. Again, that's how far you travel in one revolution. So if you're going around 5 times, you multiply that by 5, and this is how far you travel in 5 revolutions. Okay? Okay. By the way, one thing I wanted to mention to you, this is how odometers on a car work. Let me show you what an odometer is. This is an odometer. It's a counter on a car vehicle that says how many miles the car traveled. The engineers that designed the car designed it with a certain wheel size. So knowing the diameter of that wheel size, they calculate how far you travel in one revolution. So the way they calculate how many miles you traveled is, or kilometers or whatever the units are that you're working with, is they find the circumference of one revolution, and basically they're counting how many revolutions the tire makes as you drive. That's how it works. Okay, I'm going to give you one more application. Okay, here's another one with a track. How far will you travel and if you run 3 laps around a circular track? Again, you're going around 3 times. So that would be a circumference problem. They're giving me a diameter, so I'm going to use the diameter version of the formula. So it's pi times diameter, pi times 50. If you plug that into your calculator and round, that's about 157.1 feet. But that would be in 1 lap. 1 lap. They're saying that you did 3 laps. So you multiply by 3, and it's about 471.2 feet that you travel in 3 laps. Okay. I wanted to give you now an example of where we do it backwards. Here, let's say I have this real world application actually happened to me. I had to find the diameter of a pipe, but the pipe was connected, so I couldn't just measure across. So I didn't want to disconnect it. I wanted to see if I can find the diameter without disconnecting it. So what I did is that I measured the circumference with a tape measure, kind of like what I had you do last time. Okay, and then what do you think I did with that? If I know the circumference is pi times diameter, and I want to find out what the diameter is, I can just divide both sides by pi. So if I take the circumference and divide it by pi, that gives me the diameter. So that's exactly what I did. I took the circumference by taking a tape measure and measuring it. I divided it by the pi key in my calculator, and that gave me the diameter of the pipe. So here, not an application, so I'll just make one up. So let's say that I have a pipe that is connected. This is not drawn well. Let's say that I have a pipe and the circumference of the pipe, the circumference is, I don't know, let's say it's 6 inches, and I want to estimate the diameter of this pipe. So the circumference is pi times diameter. I'm giving you the circumference. I need to solve this for D. So I divide both sides by pi. So if I do this on my calculator, if I divide 6 by pi, that is approximately 1.9 inches. So that is approximately the diameter of my pipe. Okay? Okay, so that should be enough to get you going. The homework will be online. It's a homework assignment from the book. And thank you very much.